Very good morning, students. Welcome to another session of irrigation and hydraulic structure subject. In the previous lecture, we have discussed about what are the different causes of failure of earth dams. We have seen three different types: hydraulic failures, seepage failures, and the last important one is one more type of failure, that is structural failures. So these are the three important types of failures which we have discussed, and their causes and how to overcome those problems. And also we have seen the procedure or the criteria for the safe design also we have discussed. How to overcome the different failures in terms of safe criteria for design, those steps also we have discussed in the last class. Now moving on to the next topic, in today's class we are going to discuss about seepage analysis. What is the meaning of seepage and how seepage causes problems in the earth dam, and how this seepage can be controlled. First of all, how this seepage is analyzed. What are the different ways are there? So how to analyze the seepage, that we will discuss in today's class. And also what are the different methods followed. So out of which we are going to discuss graphical method in the analysis of seepage. We will discuss in this particular class. Now getting into the lecture. Now what is the meaning of seepage? Seepage is nothing but, right, it is the water which is flowing from upstream side to downstream side. It may be through the body of the dam or it may be through the foundation of the dam. Okay, so a safe dam should not be allowing any kind of seepage either from through the body of the dam or else through the foundation of the dam. It causes so many failures because of seepage, because of the seepage from upstream side to downstream side, it will create some pore pressure in the body of the dam, so that creates so many problems. So in order to analyze what should be the seepage and how the seepage can be controlled, right, so that we will discuss now. See here, seepage analysis in an earth dam can be determined by, we will take one concept, that is theory of flow, right, theory of flow of fluids through the porous media. Means whenever you take the porous media, so how the fluid flows through the porous media. So the exact same concept like theory of flow of fluids can be implemented in the seepage analysis also. Okay, the same concept is utilized here. So for this, what we have to do, we have to take certain assumptions we have to take in the analysis of seepage analysis. So what are those assumptions? Let us have a look at them. Okay, now the first assumption is, what is the first assumption here? The first assumption is, for example, if you see the rolled embankment and the natural soil foundation are incompressible. See, whatever the embankment as well as natural soil of the foundation are considered as incompressible, and as well as they are porous, right? That is the first assumption we have to make. Embankment as well as whatever the foundation material is there, soil, natural soil is there, they are porous as well as they are incompressible. Okay, and also one more important point is the size of the pores. Whatever the pores which are existing in the embankment as well as in the foundation soil, they do not change with the time, whatever may be the water pressure. If the water pressure increases or decreases, but this pore space will remain same. They do not change with the time with respect to water pressure increase or decrease. Okay, so this is the first assumption we have to take. Okay, now moving on to the second important point, it obeys the Darcy's law. So whatever the analysis we are taking, so it obeys the Darcy's law. Okay, for a given soils, the Darcy's law is valid. Okay, now the third important point is, whatever the amount of water entering into the dam, means seepage, right, whatever the amount of water entering into the dam, right, and whatever the water entering out of the dam, means going out, coming in as well as going out, is same. That is what the third assumption. The quantity of water entering the soil in a given time is the same as the quantity flowing out of the soil. Water entering into the soil as well as water going out of the soil is a continuous system. Quantity of incoming as well as outgoing will remain same with respect to time. There is no inflow is different and outflow quantity is different. It is not like that. It is assumed as same. Inflow and outflow quantities are same for a given type of soil. That is the third assumption. Okay. Now let us move on to the next fourth assumption, that is the hydraulic boundary conditions at the entry and exit are known. So whatever the hydraulic boundary conditions are there, they should be very well known at the entry point as well as at the exit point. That is the fourth assumption. Okay. Now the first, fifth point is the water is incompressible. It is a well known fact to everybody. So the same assumption is assumed as the fifth one here. So these are the 5 different assumptions which are very, very helpful in the seepage analysis. Okay. So now let us get into the seepage analysis procedure here. See, in the seepage analysis, we will take the help of Laplace equation for two-dimensional flow, right? So to calculate the seepage analysis in an earth dam, we will take the help of Laplace equation for two-dimensional flow in an earth dam. So that is given as dou square phi by dou x square plus dou square y by dou y square. Dou square phi by dou y square. So this is the equation, general equation for two-dimensional flow of fluid. Okay. So where here this phi indicates k into h, where k is the coefficient of permeability coefficient, and whereas k is h is the head causing flow, means whatever the head we are maintaining at the upstream side, so that is the head causing the flow, which is initiating the flow from upstream side to downstream side. So what is that head we have to consider here. Okay. Now see how to compute the seepage, how to compute the rate of seepage by using flow net. So already you might have known what is flow net, right? Flow net, what is flow net? So that we are going to discuss here. So that plays an important role here. Okay, so that we will see like this. We will take the net. Okay, so this we will discuss in detail in the upcoming slides. Okay, so what is this flow net actually? Okay, so flow net is nothing but it is a network of equipotential lines along with the flow lines. Means it is a combination of equipotential lines as well as flow lines. They are perpendicular to each other at meeting point, which is known as flow net. So just one word you have to remember, that is flow net is a network of equipotential lines as well as flow lines. Combination of these two is called as flow net. Remember this point. Now see here we can see there are some rectangular channels are there and some horizontal channels are also there. Rectangular pulses and horizontal channels are there. So here what is the meaning of flow channel? The portion between any two successive intervals. So this is one successive interval, right? Successive flow lines, which is this portion. So this portion is considered as your flow channel. Means the water is flowing in this channel like this. Okay. So the portion between any two successive lines is called flow lines is called as flow channel. Okay. Now coming to the whatever the rectangular box is there, this hatched portion is there. So this is called as your field. What is the meaning of field? Field is the portion enclosed between two successive equipotential lines and successive flow lines. So this is your field. This is called as your field. The space enclosed between two successive equipotential lines as well as the flow lines, successive flow lines. Okay. So this is about channel as well as field, flow channel and field. The horizontal one is called as flow channel, and whatever the rectangular portion is there, that is called as field. Remember these two also. Now here you can see in the picture. See, what is this? This line is called as, what is this line? This line is your flow lines. These are the four different flow lines. Okay, they are going like this. Okay, so what are these? These are equipotential lines. These are equipotential lines which are going like this. So flow lines and equipotential lines. So what is this portion? This portion is called as, this portion is called as flow channel. See, what is flow channel? Flow channel is that which is the space enclosed, the portion between two successive lines. Two successive flow lines is called as flow channel. So this is your one flow channel, and this is one more flow channel. This is the other flow channel. The space enclosed between two successive flow lines is called as flow channel. So what about this field? So this, whatever this rectangular portion is there, this hatched portion is there, rectangular box is there, square box is there. So this square box is considered as your field. Field is the space enclosed between two successive flow lines and equipotential lines. So this is called as your field. Okay, so this is the flow net portion we have explained here. Okay, so here delta Q is the discharge coming in each flow channel, so which remains same in each line. The discharge remains same in each line. Okay, now here you can see where B is the breadth and L is the length of the field, and the thickness is also considered as unit thickness may be taken. Okay, now let us move on to the next slide. See here, where L is the length and width of the field, as we have seen, and delta H is the head drop to the field, and delta Q is the discharge, as well as H is the total head causing the flow, which is also calculated as difference between the upstream and the downstream heads. Okay, so then by using Darcy's law of flow through soils, the equation is given as delta Q is equal to K into delta H by L into B into 1, where B is the width and where 1 is the unit thickness. Here L is the length and delta H is the head drop through the field, and K is the permeability coefficient, and delta Q is the discharge passing through the flow channel. Okay, so by using this equation we will go further. This is Darcy's law of equation through soils. Okay, suppose there are some number of equipotential drops are there, some number of fields are there. So let us see. Suppose if ND, and considering it as if ND is the total number of potential drops, right, in a complete flow net. Like in a complete flow net, let us assume these are the different potential drops. So then what happens? Okay, so in a complete flow net, let us assume these are the potential drops. ND is the total number of potential drops. So then what happens? Delta H is equal to, so whatever this we are taking it as delta H, this is the head drop. So ND is the total number of potential drops. So this is H divided by ND will give you the head drops in the flow net, entire flow. Okay, then Q is equal to, delta Q is equal to K into, if we substitute, this will be the final equation. Right, where ND is the total number of flow channels. Right, where ND is the total number of flow channels in the net. Okay, so here you can see, I think here some mistake has gone. Okay, so this is the equation. Delta Q is equal to K into H by MD into B by L. So this is the equation for calculating the discharge in a flow channel. This is equation for calculating the flow in a flow channel for one channel. Okay, if you would like to calculate for the entire flow net, we have to add the successive discharges. Okay, now let us see through the graphical representation how to calculate this flow net. So how flow net can be determined, so that we can determine we can do the seepage analysis. Okay, so for this what we have to do, we have to take the help of flow lines which are located in an earth dam. So flow lines must be located, and flow net can be plotted by a trial and error method. So with the help of flow lines located only, we can draw this earth dam flow net can be drawn. Okay, so observing the properties of flow net and following the suggestions given by the Casagrande. So by keeping these two in mind, observing the properties of flow net, what are the properties of flow net, as well as practical suggestions given by the Casagrande, by keeping these two, we can draw the graphical representation of seepage analysis, which is very, very essential in case of earth dams. Now let us see what are the properties of flow net. See here, flow and equipotential lines meet at right angles, because whenever they are going like this, but even though they will meet at right angles, so the angle between these two is 90 degrees only. That is the first property of this particular flow net. Potential lines as well as flow lines are perpendicular to each other. Next, second important property is fields are approximately squares. So if you see, these fields are approximately squares. Okay, so like that we have to draw the flow net. That is the second important property. Now the next important point is the quantity of flowing is the same in each flow channel. This is one flow channel. So for this flow channel, the delta Q remains same, and for other channel also the delta remains same. For other channel also delta Q remains same. Okay, and the potential drops also remain the same between the two successive lines. Means flow in a channel, potential drop in a potential lines, any two successive potential lines will remain same. Flowing will be same, as well as potential drops are also same for a particular flow, particular vertical drop, potential drop. So these two remains same. That is the third property. Means they are successively gradually decreasing or gradually reducing. So that is what you have to observe here. So gradually they are reducing to downward. Right? They are reducing gradually. There is no sudden drop. Flow is not decreasing suddenly, as well as whatever the potential drop is there, this is also not decreasing suddenly. Gradually they are decreasing. Abrupt changes are not at all encouraged in this particular flow net. Everything should be gradually decreased. So that is the reason our third property indicates potential drop as well as flow is same, means uniformly decreasing. Okay. Now the next important point is, whenever you find a smaller, means smaller the dimensions of the channel, whatever the channel is there, smaller the dimension of the channel, you can have high hydraulic gradient as well as high velocity of flow. As the size increases, these two gradient decreases as well as the velocity of flow also decreases. Okay. Now, last important point is, in a homogeneous soil, the shape of the curves are smooth. They are not like this. They are like smooth. Either it may be elliptical or it may be parabolic, like this. So like this you can find them. You cannot find them like this. Like this you cannot find them. Right? They are perfect squares, and these lines are, whatever the lines are there, flow lines, they are either elliptical in shape or parabolic in shape. Apart from this, none other is encouraged. Okay, so this is the information regarding graphical representation of this particular flow net. It is very important concept in terms of analysis of seepage. So by using seepage only we can analyze what is the seepage effect on earth dams. Okay, so here you can see the picture. So this is your slopes, two slopes are here. So whatever these lines are there, let us consider this as the top line. Now next second flow line, and this is third flow line. Okay, now this is one more flow line, let us assume. So like this flow lines are indicated, and whatever these verticals are there, these verticals are your potential drops. These are the potential drops like this. Now if you observe, these are almost like squares. They are almost like squares in shape, and the decreasing also gradually they are decreasing like this. Okay, so this is your flow net completely. So gradual decreasing is there, and perfect squares are there. So the decreasing is same. Okay, so this is the symbolic picture of your flow net by graphical method. So like this you have to draw the flow net in order to analyze the seepage. Okay.